machine, and those people that are competing in the competition coming up in February, gave an opportunity to practice this. My printer's not working, so I'm not able to give you this. Some of you guys should have a copy of this diagram already. First thing I'm gonna do is, David is the one who put the problem in the machine, and he sort of watched the people do it, so I'm gonna have him first give a little critique of some of the things he saw that people did right, some people, the things that we did wrong, and then I'm gonna go over it and go over the actual, this is how you're supposed to approach the problem step by step. And we're gonna troubleshoot this machine together. So I don't want you to actually tell them what's wrong with it, as far as like, this is what caused the problem. What I want you to do is just say, oh, it's running and it's not doing this, or it's not running, or whatever the problem was. And then you say, well, something I saw, people didn't unplug it when they opened it, or mistakes that they made, okay? Go on, Dave.
Okay.
All right, so one of the first things that I saw that people were doing here was they weren't using their meter enough, and they weren't confident enough where to stick the meter. Like, I know this is a high voltage thing, but people were not even using the meter, and they weren't testing simple things like our fuse up here on the noise filter. They weren't even testing power in, things like that. And another thing that I saw, one of you were testing the monitor switch and said that it was normally, the monitor switch is always going to be normally open. And you guys, one of you said that it was a bad piece, and that's something that you would just know just from familiarizing yourself with that component. And yeah, just basically what, when I troubleshoot a microwave, I usually go to, first thing is 120 to the transformer, and if I'm not getting 120 there, it tells me that it's something bad on my low voltage side, something like a bad switch, something on the board, bad relay, something like that. If I am getting 120 there, I know it's on the high voltage because I'm getting power all the way up to that transformer, and I'm not getting any heat or something like that. And I'd go testing my high voltage components there.
Alright, so the complaint was it was running but not heating, right?
Yeah, running but not heating.
Okay, can you plug it in for me, please? Okay, the problem running and not heating, I got a schematic up here, we're gonna go to the schematic, but if you were to walk up to a customer's house your first time working on a machine, what's the first thing we need to do?
Check for power.
Check for power?
See what the problem is.
Check if the main.
So
See what how are you gonna see what the problem is?
Well, ask them what the problem is.
Talk to the customer,
Yeah.
okay? In the competition, points are also soft skills. And when you go to a customer's house, you know, the very first impression a customer has of you is gonna be like, you know what you're doing, or you don't know what you're doing. And that's gonna be like, lead to repeat business as well. You know, that if you walk in there and the customer don't have confidence in you, and you make a legitimate mistake, you know, everybody makes a mistake, we're not all perfect. You make a mistake, you've lost that customer. And not only did you lose that customer, but you lost a lot of that customer's friends, because that customer's gonna call, you know, oh, my washer broke, do you know anybody? Well, I had this guy come out, but man, he almost killed himself. You know what I mean? You have to have the communication skills. You have to go in there with confidence. Even if you don't know what you're doing, you gotta sell yourself, okay? So the first thing you wanna do is you wanna ask the contestant or the judge or the customer, you gotta ask them, you know, hey, I'm here to take care of your microwave today. What, you know, I heard you're having a problem with it. Can you tell me exactly what's happening? Did you hear any noises? They can say, well, you know, the other day I went to cook a turkey and it didn't work. Okay? So say, okay, give me a few minutes, I'll check it out and I'll let you know what's wrong with it. That's the kind of thing you need to say to a customer when you're going in there. Remember, this appliance guys teach you how to fix it, but part of it's how to talk to them. Okay? And I can't change your attitudes, change your personalities, but I can guide you to think about what you're going to say and what you do with the customer. Okay, so once you do that, you plug it in. You got to make sure you have some sort of load in there, and what I mean by load is that, you know, you got to have a cup of water or something in there. And I'm going to go ahead and test it out. So running, right? Now we wanna see if it's heating. It's not heating? Okay. Well, from our prior lecture a long time ago, what were we doing as far as like, what was the things we learned to do when we turned on a microwave? We listen. Okay, so let's go ahead and turn it on and let's listen. What sounds are we hearing? Okay, I programmed it. Let's do this. What did you hear?
The beep, 2 clicks and the fan.
Okay, you heard clicking. You heard the fan running. Did you see the light come on?
No.
No? I see the light coming on. You probably can't see it because you're not in the door, but nobody can see the light from here? Let me see.
Yeah.
Yeah, you can sort of see it from the side there. If you look in there, you can see the light coming on. So you're knowing the fan's light coming on, the light's coming on, those things are coming on. The next thing is the turntable turning. And you guys can't see it from there, but I can see the turntables rotating too. Okay? What don't you hear? Before the magnetron, the transformer. Remember, a transformer is going to be a deep hub, and then right behind it, the magnetron's almost like that fly in the window, like a buzzing sound. Okay, so we see the turntable, the fan, and the light, right? So we got the light here, the turntable, which is this one here, and then the fan motor. The stir motor, we can't see it, but we have to assume, okay, here we see those. So let's go ahead and complete the circuit for those components. Okay? So we go in here, and we go through this relay, and we go out. The other things, and I'll do a different color for the other circuit, that we go here in the fan motor, stir, turntable, those components go through this relay and out. And so we see all these things are working. All right? We don't see the transformer, or we don't hear it. You can't really see the transformer running, but you don't hear it. So what kind of things can we do with this? Before we actually start breaking it down, this is what's done in the customer's house. You have to do that in your head. You know, I give you guys plastic sheets and use the erasable markers, and those of you who don't have the erasable markers still need to pick them up. And you can lay them over the top of the diagram, and you can do just like I did, trace over it without writing all over the diagram. But those lines are showing where electricity is traveling right now. What is working. So I don't have to test any of those components that have lines drawn through them. I don't have to test the main fuse. I don't have to check the thermal fuse on the cavity, the magnetron fuse, the bottom thermal fuse, the primary door switch, okay? I don't have to check the relays on the board. The board lit up, I don't have to check the transformer on the board. I mean, all that stuff is good. All right? What we didn't see operate was the transformer, right? We listened, we didn't hear it, that deep hum. So let's take a look here. How does electricity get from here to the transformer? Is here through this power relay, and out. Well, how many controls do we have that control that transformer right now? One control, and what is that?
Power relay.
That's the power relay, right? But I need to know first if I have power to my transformer. Now, before we go into testing that, David said something about the monitor switch. This is the monitor switch here. I know it's a little hard to read, but that's the monitor switch. Does electricity travel through that switch when the machine's running?
No.
What's the purpose of the monitor switch?
It monitors.
If the door don't open,
If one of the other door switches like this one doesn't open when you open the door, then it's supposed to create a direct short through this relay, through that switch, and blow that main fuse. Okay? So, right now we've had a problem with this one machine under warranty. It's not only is it not blowing the fuse in the house, it's blowing the circuit breaker in the customer's house. Before this fuse even blows, the customer's breaker blows. Okay? Well, that's definitely got to be going through this switch here. But, you know, the guys are like, man, it's blowing the circuit breaker. I can't test it. I don't know what to do. I changed, you know, the fuse is not bad. What do I do? What do I do? I said, do me a favor. Take one of the wires off this switch here. Test the microwave. Guess what? Microwave works. It runs, it heats, and everything. So they say bad monitor switch, but it really wasn't the switch. It was the bracket that held the switch. The switches were moving. The bracket wasn't holding them tight. And it's a factory defect the way they designed
The
it.
latch body,
What?
the latch body, the one that holds all the switches.
Yes. That assembly that holds the switches. And so this switch and this switch, as soon as you turn it on, that relay closes and bam, it blows the fuse. But disconnected, microwave works just fine. Okay? So that's a way to test it. But in this
But
case,
I got a question. As
Yes.
a technician, you can't remove that switch, can you? Because you're liable, right?
yeah, if you leave it that way,
Oh, okay.
and like let's say you test it and the microwave's working, and then you say, well, ma'am, I'm just gonna leave the switch disconnected. You know, I'm going to order some parts for you, but you can use it while I'm gone. What if that door opens and that customer cooks and the cat gets killed, or her baby or child gets microwave burns or something like that, or someone got a pacemaker and that thing's running with the door open? Whose fault is it?
Yeah.
That switch is there as a safety device. If you bypass or eliminate any safety device in anything, you are liable. You know, they can take your house, your car, your kids, your family, you know, who knows? So, our problem is not the monitor switch. What we need to do is, the first thing we need to do is we need to check power to the transformer. And we need to make sure we're doing the right side of the transformer, the primary voltage side. So if we look over here at the transformer, it's nice and easy for you right here. It's this black and this white wire coming in on the transformer. So I'm gonna take our meter here.
Oh, well, they get plugged in.
I know.
Full of false just today.
I'm gonna put it on volts AC here. And we got alligator clips that are insulated. I'm gonna clip it onto the white wire and the black wire here. And I got no power. Am I doing it right? What should I be doing?
Running the microwave.
Turn it on. I mean, there's no power if that transformer was off. You have to turn it on. So let's go ahead and press start. Am I getting voltage?
Nope.
How much voltage should I get here? 120 volts, right? Okay. So I don't have voltage. So I put 1 meter lead here and 1 meter lead here, and I check for voltage, and my meter said 0 volts. Does that mean my transformer's good?
You don't know
No.
that.
It doesn't mean the transformer itself is good. It just means I'm not getting power to the transformer.
Yeah.
You know, how would you check transformer? You'd ohm it out. But if I don't have voltage to it, it's not gonna work. It's not that the part's bad. I need the electricity in the part to make it work. Okay? So what kind of test could I do? Or what should I do?
Follow the line back up top to check one of those primary switches.
Okay?
Well, you know
But-
you get power from the primary switch because the other ones is working.
Because these parts are working
Yeah.
and they're going through that switch, right?
Uh-huh.
So it's not the primary switch, right?
Yeah. No.
Okay, but could this line be
Be a
bad
break.
here?
Yeah, it could be a
Yes.
break in the line.
Could this line be bad, or this line, or this relay be bad? Yeah. So here's a little trick. On a 110 volt circuit, I like to use ground. You can't do it on a 240 volt circuit, and I'm not gonna get into it today. But anywhere a 240 volt circuit, you have 1 meter lead on the circuit, 1 meter lead on ground, you're gonna get 120 volts, no matter where the break is. But a 120 volt circuit, you can use ground if you have a good ground and the plug has a good ground. Watch what happens. This wire here is my black wire. This wire here is my white wire. Which one of them is line 1, the line of power coming in?
BK.
The black one. Okay? So if I put a meter lead on black and put a meter lead on ground, what should I get?
120.
120. Okay. So I'm going to show you a little different way to make a test, okay? So I'm going to leave my meter lead on the black wire on the transformer. And I'm gonna take this white one off, and it just so happens I have a ground wire right here on the frame of the machine. So I'm checking black, which is power coming into the transformer. I'm checking ground. And I'm gonna press start.
There you go.
I have 120. So, what does that mean?
That means, the line one is good.
That means power's coming into the transformer. I just said a minute ago, I don't have power. Well, it takes two lines to make voltage. But the test I made is telling me that the black line coming into here
It's good.
to ground is got 120 volts. So I know back here is good. Yes, you got a question?
Okay, can you do the same thing with the white wire too?
Watch. I'm gonna put the meter lead that's on black, I'm gonna put the meter lead on the white. Let's see, what do you think's gonna happen? Settle, okay? So I'm gonna put this meter lead here, and I'm gonna put the meter lead here, and I'm gonna press start. What do I got?
120.
120.
So transformer,
Transformer is open.
Transformer is not open.
it's not good.
Because what should white to ground give me?
Zero.
0 volts.
Why
I
is that?
have voltage from white to ground. What's happening is that the winding in the transformer is good. Somewhere here, I'm losing my voltage. From here to ground, I have 120. So line 1 is coming through the transformer. It's feeding through. Okay? I'm still getting power on the neutral side because it's not neutral anymore. There's a break somewhere here.
I see.
Okay, so I gotta keep going, test. Now, when we check a circuit, now, and I wanna like say something here. Here's a switch, a light bulb, here, and I'm gonna put a break right here. This is my line 1 side, oops, I'm sorry. This is my line 1 side, this is my neutral side. I'm gonna close this switch, and my first test was from here to here, and I had 0 volts. The light bulb is representing the transformer. Y'all follow me so far, right? Then I went from, and I'm using a different meter, I went from here to ground, and I had 120. That meant from here to here, I had line voltage. Now you can see, I made the break here, you can see the break. In this circuit, you don't know where the break is. But if I move this one to here, and I get 120, line 1 is just coming through the light bulb. You're saying, but that's the neutral side. It's not neutral if I have something broken here. It's not getting back to neutral. If neutral was good, and I tested here to ground, I won't get a reading. Okay? Now that's not the way I always want you to test. I want you to put both meters here. If you don't find it, but you find it here, then just keep going back till you find it. But I told you a minute ago, I'm gonna do it a different way. I'm just gonna keep moving this meter lead here, leaving this one on ground. Now watch what happens. When we test a circuit with switches and wires, the switch could be bad or the wire could be bad. The load can be bad, which is light bulb, transformer, whatever, or the wire can be bad. When we make a test with voltage, different from ohms, we're testing an entire circuit. We're testing the wires, the switches, and everything. When I checked from here to ground and had voltage, that meant everything in this circuit up to here is good. There's no way I'm going to get a voltage reading from here to here if one thing there is bad. So when I'm doing a voltage test, I'm checking everything in that circuit right back to the plug. When I went from here and had voltage to ground, it's because I went through here back. Now, if I find voltage here, I have to keep going till I lose it to find out where it's lost. Where would my next test be if I tested from here to ground and had it? Where's the next test going to be after that? Power relay. Which side?
The pink one?
The other side.
This side or that side?
That side.
The right side.
The right side.
Yeah.
So if I go here
Look at the top.
If I go here, from here, and I lose the voltage, what am I testing at this point? The relay?
You
No,
check
those-
the
that-
It's a wire.
wire.
If I lose it here, the wire's broke. If I still have voltage here, it's still feeding voltage up to this point. Maybe my relay's bad. So if the relay was bad, I won't have voltage here, but I'd have voltage here. Vice versa, yes.
So a load by itself is not enough to stop a line wire coming through?
No, because when you have a break in a circuit like this, the load is not drawing. Normally, when the load is running, we have what we call a voltage drop. Okay? If I put my meter here and here, I might not get 120 volts. If the light bulb's going through, we have what we call a voltage drop. But when the light bulb's not running, the light bulb just becomes a path. It's when the current is flowing, the voltage drops.
So you said,
It's almost, let me finish explaining 1 second. It's almost like, you know, you washed your car with your garden hose and it has a little trigger on the end, right? You're done washing the car, you lay it on the ground, and then you go and you turn the water off at the wall. Well, if I grab that trigger and pull it, does anything come out? For a second, it comes out because it was under pressure. Voltage is pressure. But then afterwards, the voltage will drop because there's no more pressure coming. Okay? So what's your question?
so yes, so you said when you check 220 volts, so you.
I
you
don't,
can-
let's not get into a 240 volt circuit because we're not talking about that now.
Oh, no, I'm just like,
I
want
can
to
talk
know,
about
like,
that
if
later.
you-
I don't
if
wanna,
you-
I don't wanna
Okay,
change what we're doing.
okay.
Okay, so if I have voltage here and then I lose voltage here, that means I'm getting what? I'm getting my neutral through this side and the voltage from here is not coming there. Okay, so we're losing for that drop. So I have it up to here. My next test is the relay on the board, yes.
Now you said if you check it from the other side of the transformer and the inside of the relay.
I don't have both meter reads here. I'm still using ground.
Oh, okay.
I went here and here and I didn't have a voltage reading.
Okay, good. You
I
got
went to ground, I had a voltage reading. I moved this one, I still have a voltage reading in ground. So the only way I have voltage reading in ground is if the power line is coming in. So I'm here, the next step is to move this one here, I'm still on ground. If I have voltage, that's because the line is here.
Good.
If I don't have voltage, but I have it here,
Broken
that
somewhere.
means this line is broke. Okay? So I'm gonna take this white one off of here. And I'm gonna go to this one on the transformer here. I think I'm on the right transformer. Yes. And let's go ahead and press start.
Yeah.
I still have voltage, right? Okay.
Why, it's good.
So I have voltage from here to here. Let's go to the other side. Now, let me see here.
You need a light?
Yeah, you got your light, Dudley?
Here. Hey,
Yeah,
don't turn
yeah.
it to this as you
You
please.
got your solar cell?
Don't turn.
You put it in my eyes. Okay, I was on the wrong relay.
Good job, Dudley.
I need to be on the relay above. I was on the wrong relay. That relay that I just tested was this relay here. Okay, I gotta go to this relay here. It had two sets of white wires on it. If you look, this one here has got the white wires on it. I was on the one below it, which had the pink and red, the red and black. So I'm gonna go to this meter lead here, and I gotta be careful. This whole time I'm doing it, this thing has got live voltage, okay? So I'm gonna go to the white wire here and do that test again, because I was on the wrong wire. I don't have voltage. Okay? So, hold
No,
on, not
you
done.
gotta turn the top, like the middle, in the middle. No, not that one, where your finger, okay. Thank you.
So I didn't have voltage here,
Yeah, okay.
but I had voltage here, so that meant the white wire coming off the relay to the transformer is bad. Now, I need to prove it. Normally, I'm done. I go into someone's house, I made how many tests? 1, 2, 3, 4 tests, I'm done. Remember, the most important part was listening, finding a circuit that was bad, finding out what do I gotta test. Remember, the relay could be bad or here could be bad. Sometimes when people troubleshoot, they lose sight of these wires. What do I need to confirm what my problem is?
Actual wire.
So what do I do?
Continuity of the wire.
Continuity of the wire. So what we're gonna do is we're gonna unplug the machine. And I'm gonna take one wire, the white wire off the transformer here. And I already have this white wire still up, connected with the relay. And I'm gonna go to ohms. First thing I'm gonna do is I'm gonna test my meter is working. I put it on ohms and you see it go to all zeros.
Okay.
So it's working. I'm gonna go to this white wire right here. Put my alligator clip on there. I didn't get no deflection of my meter. So that told me the white wire from the board to that transformer is no good. And that's what we did, we cut the wire. That's the problem we put in there. In this contest, if that was the problem, and I didn't stop to explain every test and every step that I did, how long would it realistically take to make those tests? 5 minutes?
Like 3, 4 minutes.
4 minutes.
But the testing part was 5 minutes. The 10, 15 minutes it takes you in a customer's house, customer instruction, customer communication, taking the microwave cover off because you can't get to it from the front sometimes. Okay? Using the schematic and tracing that circuit out. That's what you need to do. You need, you know, if you're gonna go vacation, I say, you know what, guys? I'm gonna give you a free trip to North Carolina. I got a cabin up there, can fit about 60 people. It's like a hotel. I'm gonna give you guys a free week with ski rental up there and everything, snowmobile, everything. You're all invited to go. You gotta get yourself up there. You gotta drive up there. Do you just get in your car and drive?
No.
Oh, what do you need? The address? And then when you get the address, what do you gotta do? Google Map? Or you look at a map?
Yeah.
And say, I gotta take 95 and get off on this one and go here, go there. That is your map. That wiring diagram is your map. You can't start testing till you know the path. And what path is good and what path is bad. If I told you I-95 shut down because they had a terrorist attack and a bomb blew it up, you have to find another way, the turnpike, or whatever. You have to use that schematic. The schematic is going to give you that step-by-step direction, and you have to read it. You have to understand, where am I on the diagram? And, you know, it was real easy for me to look at it and go right to the component on the machine. That's a hard thing for people to do. I tell you, when I first learned appliances, I look at a diagram, I say, aha, I can see that circuit all day. And I'm gonna check power to transformer. And I sit there and stare at the machine, I say, well, here's the diagram, and here's the 2 points on the diagram. Where the heck is that in the machine? I don't know where this is in the machine. I can't put the two together. I see these lines, how does that mean the machine? It's the repetition and the practice, the hands-on is going to give you guys that when you're working on the machine. You need to read diagrams. A lot of people say, well, I take diagrams home, study them all day. I says, really, what are you studying? You're looking at it, what are you learning? You know what I mean? You need to have the diagram in the machine and look at the part on the diagram and then find that part on the machine and say, if I tell one of you guys, I want you to put the meter right here and here, on that L, not that L, that point. Well, you guys need to be able to take that meter and go right to it, not right away, but you have to look at the color wires, you have to know what the symbol means. That's what we're gonna do next week. I'm gonna get a machine and I'm gonna have you guys, I'll give you a diagram a day ahead of time, Tuesday. You guys can look at the machine and so forth. And one by one, I'm gonna call you guys up and then give you a point on diagram, say here and here, and you're gonna put your meter there.
That's nice.
And you're gonna make that test. Might be ohms, might be voltage, I want you guys to tell me, I did this, yeah, it's a good reading, because I might put a problem in there somewhere too. You might not get the problem, you might get the problem. I might not give you the test that actually shows the problem. You say, no, I checked here to here, and this part is good. You need to tell me your meter's reading good. Alright, so Tuesday and Wednesday next week, that's what we're gonna do. Alright, anybody got any questions on this? Yes, Dudley.
Okay. If you cut the black wire, the problem wouldn't be the same. It would be a completely different
I
problem.
wouldn't have voltage at all.
Yeah.
Now, the way that we're really supposed to attack this problem, let's go ahead and let's look at that real quick. Why is this so small? The way we're supposed to do is check voltage to the transformer. Let's do it the way we talk about it. I'm gonna put this white wire back on here. And I'm gonna put it here and here, black and white, here. Gotta put my meter back on voltage. We don't wanna blow up my meter.
You gotta plug that machine too.
Yeah, I know. But now this is the way most of the tests are gonna be. What?
The board works.
The board works because it beeps?
Yeah.
Well, it may not work just because it beeps. The speaker works.
Okay.
Okay, so stop clear. Do we have voltage?
No.
Okay, we don't have voltage. Okay? Now, when we're troubleshooting, we need to know how to troubleshoot. The thing is I need voltage at transformer. I put both meter leads here. I don't have voltage. So my problem could be from here to here. My problem could be from here to here. You all know this is my problem, right? So, going back, I put my meter here in ground and I had voltage. I've already tested half the circuit out. I know this half the circuit's good. If I just take this meter lead and move it right here, watch. I'm gonna take this meter lead off the white, and go back to white on the transformer, and press start. I have voltage.
You say you do have voltage?
Yes. Now, before I didn't have it, right? I lost it the other way, right? Because I was on the neutral side with both meter leads. Now I got one meter lead on the power side, one meter lead on the neutral side. Do I have voltage right now? It's off. When I press start, do I have voltage?
Yes.
Yes.
Why is that happening? Why am I having voltage now, but I didn't have it right now?
Because,
I didn't say it right, but-
Something